Hello and welcome. This is Algebra 1A. We're working on the chapter of equation solving. The section title we're working on tonight is 3.3, Equations with Distributive Property. And the Pizzazz pages that will work in coordination with this are Pizzazz page 40 and 42. Make sure that you get a moment, or take a moment rather, to add your name and date in. And we're going to go ahead and do some vocabulary here momentarily. So instead of doing traditional vocabulary like we have in the past, we're going to remind ourselves what distributive property looks like. So we're going to have an example of just basic distributive property up in our example for our vocab. So if we had A times the quantity of x plus 1, or x plus y, we're going to want to distribute the outside term to each term inside. So the A is going to be multiplied to both the x as well as the y. So we're going to plug in where we see the x and the y, and notice that the A is both on each side of this. And when I multiply A times x, I get AX. And when I multiply A times y, I get AY. Let's take a look at an example using some numbers, maybe make it a little more tangible for us. So we're going to use the example of 3 times the quantity of 9 minus x. So 3 times the quantity of 9 minus x. Here, this is a situation in which it's going to require the distributive property. And here I'm going to multiply the 3 to both the 9 and the 3 to the x. Now in this case I can choose to add the opposite with the subtraction and make it a negative x, or I can leave the subtraction alone. So here I chose to leave the subtraction alone, and I get 3 times 9 to equal 27, and subtract 3x to give me minus 3x. Alright, so we're at a good place where we can take a look and remind ourselves now of what this distributive property means. And the reason that each of these situations requires distributive property is because the quantity that is inside the parentheses is not something which we can simplify without using distributive property. We need to use order of operations normally tells us to simplify within the parentheses. Unfortunately, if we try and simplify 9 minus x, we still get 9 minus x. So there's no way to simplify that without going ahead and distributing the 3 through. So let's take a look now on the key concepts, and let's talk about a method for equations using distributive property. So add that title. Again, the title is the method for equations using distribution. And we're using the distributive property when we're talking about that. So when we're talking about using distribution. After we've got this title for the method, we're going to write down the first step. So if the variables are split into multiple parts, so perhaps we have to combine some terms. So if the variables are split into multiple parts, we're going to want to use the distributive property to remove the parentheses. So there's this piece of, hey, I see something that I need to combine together. I can't combine them until I distribute. So make sure that when you see variables and when we're equation solving, and if there is an opportunity to distribute, in this case, if we have variables that are split, maybe some that are terms that are inside the parentheses and some that have terms outside the parentheses, that's when we're going to want to use this distribution. The second type would be when we have to simplify using combining like terms. Then apply the principles. I'm ahead of myself. So make sure that you simplify using combining like terms, and then apply the principles we've been using on notes 3.2. So a quick recap for the method. The first step is if the variables are split into multiple parts, we want to use distributive property to remove the parentheses, because we can't simplify inside the parentheses. So in order to reduce and get rid of the parentheses, we need to distribute. The second step is to simplify by combining like terms, and then using the principles from notes 3.2, which were our two-step equation notes. All right, from here, let's take a look at when we might want to use distributive property and when it might not be perfect for us to use the distributive property. So the first time in which we're going to want to use the distributive property, so let's put that title in, is the following example. 3 times the quantity of x plus 5 plus 6x equals 21. In this situation, we will want to use the distributive property because we have the terms that are separate. So here we have an x term and here we have an x term. These are multiple terms that we want to go ahead and distribute the 3 to the quantity of x plus 5 and go ahead and solve. Now, a situation when perhaps, to counter it, when we wouldn't want to use the distributive property and it looks very similar. What if we had the distributive looks like 3 times the quantity of x plus 5 equal to 21? Now this is a particularly interesting case where we could use the distributive property, but it would actually add additional steps to our process. When I take a look at this situation, when I don't want to distribute, I notice that, hey, if I just got rid of the 3 times the quantity, if I did that and undid the 3, I could then have the x plus 5 and work from there. So this might be a better situation in which I want to simply just divide by 3 on each side, and I would end up with x plus 5 is equal to 7. A much simpler process rather than distributing and getting to the same point a few steps later. So this might be something to be aware of. When our terms, we only have one variable, so in this case we only had that one x, we didn't have multiple terms that had a variable, we're going to want to take a look and say, hey, can I actually divide by the outside term being multiplied and make this a simpler situation without distributing? So let's take a look at our first example when we're going to want to solve each equation, and then we're going to check each of in the solution to the original equation. Now remember, when we do our check, we always want to rewrite the original equation, substitute, and solve using order of operations. So our first equation says 4 times the quantity. So 4 times the quantity of x plus 3 minus 5x equal to 18. Now here, this is a situation when I want to use distributive property. And the reason is because I have an x term over here in the parentheses, and I have an x term right here that's outside the parentheses. So that requires me to use distributive property and multiply 4 times both the x and the plus 3. So we're going to plug those things in. We're going to get 4x plus 12 minus 5x equal to 18. Combining like terms, we can put the x terms together and get a negative 1x plus 12 is equal to 18. Solving for ourselves, we can subtract 12 from both sides, still giving us negative x equal to a positive 6. And we're going to want to divide by negative 1 and find out that a positive x is equal to a negative 6. We can just alternate those. So if we had a negative x equal to positive 6, we can now have a positive x equal to negative 6. Our check is going to require the original rewrite of the problem. So 4 times the quantity of x plus 3 minus 5x equal to 18. And I'm going to check the value, my solution, into this equation. I believe x is negative 6, so where I see x, I'm going to place negative 6. And once I place negative 6, I can go ahead and simplify using order of operations. That's going to tell me I can simplify this first and get a negative 3. So then 4 times negative 3 minus a negative 30 is equal to 18. That minus a negative that we have happen over here can give us this positive, this adding a positive. That's what happens when we have minus a negative. It becomes a plus plus. So 4 times negative 3 gives me a negative 12, and so negative 12 plus 30 is what I'm adding to hopefully get 18, and in fact it does equal 18. This allows me to box in my answer of x equal to negative 6. So we're going to box that answer in. Now we're going to move on to the back side of this note sheet. Add the section title for us, please, of 3.3, Equation Solving with Distributive. And we're going to leave the vocab and key concepts on this page blank for now. We might come back and add pieces in case something comes to mind that would help you on this situation. Our second example we're going to go through is 8 times the quantity of 7 minus y is equal to 24. Now in this situation, I'm actually going to move this, so bear with me one moment. Thank you, so I just moved the page. Still the same problem of 8 times the quantity of 7 minus y equal to 24. And in this case, I'm going to go ahead and actually solve this in 2 different ways to prove to you that this can be done both with the distributive property and without. We're actually going to start the 2 ways with the without the distributive property. This is the faster of the 2, and I can recognize that this is something I can use because I only have a y term, my variable term, is inside the parentheses. And that's how I can recognize that I can choose either way to solve this. We're going to start by dividing by that outside term just to get rid of it, so I'm left with 7 minus y on the left-hand side. So if I divide by 8 on both sides, I find that I have 7 minus y is equal to 3, a positive 3. And then I'm going to go ahead and solve for y. This requires me to subtract 7 from both sides, and I will get negative y, so be sure you're carrying that negative with it. Negative y is equal to negative 4. That would mean I can divide both sides by negative 1 and get a positive y is equal to a positive 4. Let's go ahead and check this answer. So we're going to rewrite our original equation. That requires us to say 8 times the quantity of 7 minus y equal to 24. And I'm going to plug in where I see the y, I'm going to plug in a positive 4. This gives me 8 times 3, because 7 minus 4 is 3. And 8 times 3, in fact, is 24. So I can do a check on that and box in my answer. The second way to go about doing this is going to be using distributive property. And this is a way for me to prove to you guys that this actually works. So we're writing the exact same problem. Okay, you don't have to write this over here. You don't have to write that. I just want you to know that we are working on the same problem above. We're just going to solve it in a different way. So 8 times the quantity of 7 minus y is equal to 24 can be solved in the following way, using distributive property. So the 8 can distribute to the 7 and also to the y. So I'm going to plug in and find out. I was a little fast. We'll go back a couple steps.